You remember what we talked about last time? AI is about to break the power grid. We're building data centers faster than we're building transmission lines. Training GPT-6 might require more power than most countries even have on tap. The whole AI stack, from models to inference to deployment, is bottlenecked by one very real, very physical constraint: electricity. But what if we stop trying to upgrade the grid, and just leave it behind? This isn't a metaphor. There's a new kind of data center coming, and it's not in Wyoming or Iceland or the bottom of the ocean. It's in orbit. This is the bet StarCloud is making. You might have known them as Lumen Orbit. They just rebranded, raised another round, and they're going where no data center has gone before. Literally. So let's unpack that. Because if you're rolling your eyes right now, I get it. Space data centers sound like vaporware. Like crypto meets cloud meets rockets. Silicon Valley's trifecta of hype. But strip away the pitch decks, and there's something real here. Something that directly answers the most urgent constraint AI is facing today. Let's talk through it. First, the problem. And if you caught my last breakdown, this will sound familiar. Modern AI doesn't run on clever code. It runs on clusters. Each training run for a frontier model burns as much energy as a small city. These clusters aren't sipping electricity. They're gulping it in massive, unpredictable bursts. A single GPU rack, just one rack, can pull 120 kilowatts. Now scale that across a facility with tens of thousands of racks. The math gets existential. In Europe alone, data center demand is set to more than double by 2030. That's not a growth curve, that's a tsunami. And the response so far? Lagging. Dublin has paused new builds. Frankfurt's grid can't keep up. The US is better off, but not by much. Transformers are backlogged years. Lead times for power access? 3 to 5 years if you're lucky. So we've hit a wall, and that's where StarCloud comes in. Their thesis is simple. Stop fighting for land, permits, and electrons, and just build the damn thing in space. No, seriously, the numbers are kind of insane. In orbit, solar power doesn't deal with clouds, or night, or atmosphere. It's 24/7 irradiance. Panels get about 40% more sunlight all day, every day, and because there's no air, you don't need chillers. You just radiate waste heat directly into the cold vacuum. Space is a natural heat sink, 270 degrees Celsius ambient, and that means lower power costs, lower cooling costs, and zero water usage. StarCloud estimates they can run at around $0.002 per kilowatt hour. That's about 20 times cheaper than the US average today. It's not just about cost though, it's about scale. On Earth, we're talking about data centers hitting 100 megawatts, maybe 300 in the wildest belts. But for the next generation of AI models, think Llama 5, GPT-7, we're looking at gigawatts of compute. Multiple. StarCloud's concept scales to 5 gigawatt clusters, more capacity than some entire national grids. And yes, that's physically possible. They're using modular containers. Each one rides up on a reusable heavy lift rocket. A single launch drops 40 megawatts of compute, GPU racks, power, thermal systems, all self-contained. With the right cadence, they could deploy a 5 gigawatt supercluster in under 3 months. No permits, no NIMBY lawsuits, no waiting for a transformer that doesn't exist. Now let's talk about the obvious risks. Radiation is real. So is orbital debris. StarCloud's solution: modular shielding, adaptive maneuvering, and full end-of-life decommissioning plans, either controlled deorbit or salvage ops. They're also banking on optical communication, laser links to Earth, bypassing congested radio bands with higher throughput and lower latency. And let's be clear, this isn't just theoretical. StarCloud's first GPU in space demonstrator is scheduled to launch on a Falcon 9. It's not a science fair project, it's NVIDIA-class silicon in orbit, stress testing deep learning workloads, and they're not alone. Thales Alenia backed a European Commission study saying orbital data centers cut emissions/water use and sidestep grid congestion. Axiom Space is planning orbital compute nodes. Even Microsoft's been quietly testing submerged servers and off-world experiments. So why does this matter now? Because the AI arms race isn't slowing down, and the grid isn't speeding up. This mismatch between ambition and infrastructure has to be resolved somewhere. And it's increasingly clear somewhere might be 600 kilometers above your head. There's something poetic about it. We built the internet thinking it was weightless, cloud, virtual, untethered. But AI has revealed the opposite. It's physical, heavy, tied to land, copper, silicon, and steel. And now we're reaching for orbit to stay ahead of our own demand curves. So here's the real question. If we start building clusters in space, who controls them? Who governs orbital compute? Who has jurisdiction over a data center with no zip code? Who decides what models it trains, what data it stores, and how secure it is? This is the next front in cloud geopolitics, and it's coming faster than most people realize. So let me ask you this. If your job, your startup, your research depends on AI, you've probably obsessed over model architectures or GPU specs or data pipelines. But have you thought about where those models will actually live? On Earth or off it? Let me know in the comments. Would you trust an orbital data center with your compute? Or is this just another tech fever dream waiting to crash into reality? And if you're still watching, thank you. Share this with someone who still thinks the cloud is just a metaphor.